Solutions to the problems on electrostatics. The problem is on dielectric constant. Dielectric constant, it is a materialistic property which reduces the electrostatic force between the charges. Here there are two charges in the space. The space between them is vacuum, empty space. If you place or the space is filled with some materials which may be in the form of gas, liquid or solid. If the space is filled with molecules or material, a material may be in the form of gaseous state, a liquid state or solid state. That material will reduce the magnitude of electrostatic force between the charges. The magnitude of reduction in force refers to dielectric constant of the material. That we need to calculate the dielectric constant of material. That how we can calculate, that is a problem based on it. Now there are two charges in the space, Q1 and Q2, the magnitudes. The problem I am reading. The space is vacuum, empty space. Let the force, Coulombic force be F. That is the maximum force arises in empty space. Now the space is filled with a liquid, some liquid material. The electrostatic force is reduced to half of it. Electrostatic force is reduced to half of it, half of the force. Even if the distance between the two charges is reduced to half of it, if this is R, if the distance is reduced to half of that, even in presence of that, that is, in spite of it, the force is reduced to 1, that is 1 by 2 of this force. If that is the case, what is the dielectric constant of this liquid taken in between these two charges? It is a calculation of dielectric constant of a material. So like this, we are calculating the dielectric constant. So the same charges, distance is R. Electrostatic force is F. Apply the Coulomb's law. What is Coulomb's law for vacuum? The force, electrostatic force is, so write the formula of the Coulomb's equation, 1 by 4 pi epsilon naught. Epsilon naught stands for permittivity of the space. I explained it in the previous class, meaning of permittivity, epsilon naught. And Q1, Q2, their magnitude of the charges. R is the distance between the two charges in accordance with the Coulomb's law. So, in the same way, let us apply Coulomb's law for this. But the space is filled with the material, liquid material. Here the force is, in presence of liquid, Coulomb force is FL, or FM also you can write medium. FL is a Coulombic force between these two charges, same charges, but liquid is taken here. The force is F by 2. Here F of, there is half of this. So 1 by 4 pi epsilon, epsilon for the material, that is permittivity of the material, into Q1 into Q2 divided by the distance of separation. Now the distance of separation is not R, r by 2, that is whole square, r by 2 whole square, square of the distance of separation. So we have these two equations. Using these two equations, let us see how we can able to solve the value for, that is, dielectric constant. Take the ratio this by this, that is f by this, f divided by f by 2 is equal to, this is numerator, this is denominator, and simplify what we get, similar term get cancelled, q1 q2 r square, there r square is removed bracket, is 1 by 4 left over here, and 4 1 by 4 pi 1 by 4 pi, but epsilon naught f by f by 2 here left hand side 2 equals right hand side this goes to numerator, this comes to, this goes to numerator, this comes down to numerator, that is denominator overall, epsilon by epsilon naught, and this 1 by 4 is here, after the bracket is removed it becomes into 1 by 4, that is it is denominator not is 1 by 4 overall denominator. Simplify that. So it remains, all get cancels, remaining only this with these equations. So epsilon by epsilon naught, that is cross multiply, 2 into 4 is 8. So this ratio, it is called dielectric constant of the material, relative permittivity. That is permittivity of the material divided by permittivity by free space, relative permittivity. So this relative permittivity is 8 for this liquid. It says that it is same as, so if epsilon by epsilon means it is force by force, force in vacuum divided by force by liquid. So this ratio is 8. That means if a liquid is placed, the electrostatic force is reduced by 8 times. If you remove the liquid, electrostatic increase by 8 times. That is ratio is 8. In absence of this, it increases to 8 times. In presence of this, the electrostatic force reduces by 8. So it is a meaning of what is that? That is dielectric constant. That is the actual significance or meaning of the term dielectric constant, relative permittivity. So how much the electrostatic force is reduced, that is the one which is referred by dielectric constant of the material what you take in between the charges. That is the actual meaning. This is how we evaluate the dielectric constant of any material by calculating what is that in this way, by measuring these quantities and calculating this. Now the problem is based on electric field. Look at that, electric field at a point in space by multiple charges. Electric field at any point in the space by multiple charges, which is similar to the problem what you have solved on the electric force. So electric force means Coulombic force, which I have solved in the previous problem. So electric field, now the problem is electric field by multiple charges. The definition for electric field at a point in the space. Definition for electric field at a point in the space is, that is E is equal to kq by r square. What E stands for? E stands for electric field intensity at a point. It is the magnitude of electric field at a point in the space, and it is due to the presence of the charge, that is static charge, that is q, magnitude of charge, and r is the distance between the point where you are finding this electric field and the charge q. So R is the distance between the point and the charge, and K is Coulomb's constant. Remember this is a mathematical definition for electric field. KQ by R square. KQ by R square E. So apply this equation everywhere where we need to solve the problem. Now there are two charges in the space, that is plus and minus. Here also two charges in the space and the point here. So at this point we are calculating the electric field due to these charges. This is a geometry of arrangement, the point and the charges in the linear fashion. Here this is a geometry of arrangement. This is a polygon type similar to the previous one. Previous one is electrostatic force, now this is electric field. Polygon means two charges and the point, are in this geometrical, what is that shape, geometrical arrangement. Similarly, we have three charges and the point in the space are in this geometrical shape. Here the charges are three, multiple charges. Here the charges are two, multiple charges. And the point here we need to calculate what is the electric field at this point due to these charges. Electric field at this point due to these charges. Electric field at this point due to these charges at this point. So there is a problem. Solutions are given here, and just to briefly explain how the solutions we arrived at. Here the problem, I will read the problem. There are two charges in the space, that is plus 1 microcoulomb and minus 2 microcoulomb. And you have to find out what is the electric field at the midpoint of these two charges, which are separated at a distance of 2 centimeter. The two charges are separated by a distance of 2 centimeter at the midpoint on the axis. That is the axis of the midpoint on the axis. What is the electric field intensity? That is the problem. First, you look at the point. At this point, two electric fields are operating. Electric field due to this charge and electric field due to this charge. Electric field at this point due to this charge is, that is, this quantity of charge is E1. Direction is this, because there is a repulsion between this and this point. This is plus, this is also, what is that? P is always plus point. And the electric field at this point due to this charge is, this is U2, magnitude of electric field. Direction is this. It is a repulsion between this point and the charge. So E1 is the electric field due to this, E2 is the electric field due to this, and direction is same along the same line. What is a net electric field? Net electric field is the vector sum of these two charges, these two electric field. Vector sum of these two electric field. And the electric fields are in the same direction. The vector sum is just algebraic sum of these two, because same direction. No difference in the angle between the two vectors. If that is them, just algebraic sum. Therefore, you find out what is E1 and what is E2. First, write mathematical definition of E1. Assume that it is a Q1 and this is Q2. That is same equation. At this point, K Q1 by R square. The distance between this point and this charge is 1 centimeter, because it is a midpoint. Distance between this point and this charge is 1 centimeter. That is R is equal to 2 by 2, 1 by 1 centimeter. The electric field at this point due to charge is K into magnitude of the charge Q1 divided by R square, distance of separation. E2 is equal to, at this point, K into Q2 magnitude of charge divided by R distance of separation. This is Q2 is equal to minus 2 microcoulomb. It is sum. Vector sum means algebraic sum, same direction. The net electric field at this point is equal to this same equation, taking common factor, remaining is this. Now the data is given. What is the value of R? The distance between these two charges is 2 centimeter. Then R is equal to 1 centimeter. This distance remains same. R 1 centimeter. And the amount of charge, substitute for this, and amount of charge substitute for this. This is 1 microcoulomb. It must be 10 to the power of minus 6 coulomb plus 2 into microcoulomb 10 to the power of minus 6. It is micro. Write it in SI unit. Substitute for micro 10 to the power of minus 6 coulomb. So this is the charge in SI, and value of R in SI, that is centimeter. So 1 centimeter is 10 to the power of minus 3 meter in SI. So R is equal to this, whole square is whole square, and value of K, substitute for value of K, Coulomb's constant, 9 into 10 to the power of 9 in SI. Since the value of K in SI is 9 into 10 to the power of 9 into 1 into 10 to the power of minus 6 plus 2 into 10 to the power of minus 6. This is 1 minus 2. Minus 2, that is magnitude, you don't take minus plus. That is 10 to the power of minus 3, minus 6 is common, take out as common factor. This will get cancelled, over 10 to the power of minus 6. And remains, what is that? 1 plus 3. And take out common factor, remains 1 plus 3 in the bracket, 3 overall. 3 into 9 is 27. This will remain 10 to the power of 9. This will get cancelled. And this is N C to the power of minus 1. That is Newton per Coulomb, unit of electric field. Unit of electric field, Newton per Coulomb. Look at that. Finally, we arrive at this numerical value. Answer: 27 into 10 to the power of 9 Newton per Coulomb. What is that? It is the electric field strength at this point due to these charges along the axis. The point is the midpoint along the line. Next problem, here the same that is by multiple charges, number of charges remains same. Of course, one is Q, other is plus, and other is minus. Both of them have same magnitude, Q and Q. And the point is not along the line, the point is at the vertices. That is, the charges, the two charges are the two vertices of the triangle, and other point is at the other vertices of the triangle. What type of the triangle is this? Geometry of arrangement is here same angle, that is same angle, equiangular and equilateral triangle. That is, lateral means all sides are same, A. All angles are same. All angles are same. That is equiangular, equilateral triangle. The charges at these vertices and the point at these vertices. Now, the problem is we have to calculate electric field at this point due to these two charges, same charges. Of course, one is minus, other is plus. So for that we need to do some geometry. Here, what is the geometry? At this point there are two electric fields are operating. Electric field at the point due to this charge, and electric field at the same point due to this charge. What is the electric field at this point due to this charge is E1. Direction is this because here plus electrostatic repulsion between these two. Here the electric field at this point due to this charge is E2. The direction is this, because of minus there is an attraction between this point and this charge. Direction is this, not like this. E1. Right, what is the magnitude of this? Magnitude of this using the mathematical definition. So E1 is equal to at this point K into this charge divided by distance of separation A square. E2 is equal to K into Q, that is Coulomb constant into magnitude of charge. Don't take the sign. Divided by A square, distance of separation. Look at this. E1 is equal to E2. No doubt about it. That is E1 is equal to E2 is equal to E. That is a 1E. Now, what is the net electric field at the point? Because there are two electric fields are operating, that is E1 and E2, but the directions are different, not along the same direction. The direction is one like this, one like. The difference in direction is by 120 degree angle. Why 120 degree angle? This is 60 degree and this is right triangle is 180. Minus of 60 is 120. The angle between this line and this line is 120 degree. The angle of separation between the vectors is 120 degree. For this vector sum, so net electric field at this point is vector sum of these two electric fields. So difference in angle, we use the formula, standard formula, which I have used in the previous class. That is, the formula is resultant. If there is a difference, if the two vectors differ by angle, same angle only, algebraic sum. But different angle means you have to sum like this. Resultant vector is, that is a standard formula. Root of that vector, this is cos theta, angle between these two. Since E1 is equal to E2 is equal to E, that is this E1 E2 cos same, therefore it becomes to E plus E, 2E square cos 120 degree. So you know the cos 120 is minus 1 by 2. That is 2 and 2 cancel, minus into plus becomes minus E square. So 2E square minus E square is E square, root of E square. Root of E square means E. Resultant vector, that is net electric field at this point. Net electric field at this point is just E. What is E? It is same as KQ by A square. Both are same. E is KQ by A square. The magnitude of the electric field at this point due to these two charges is vector sum of these. So after doing so, we get E. What is E? KQ by A square. What is K? Coulomb's constant. Q is the magnitude of the charge. These two charges are same. And A square, the distance between them are same. A square. That is the equation. So this is the equation for this problem. Now you can set any numerical problems by assigning what is that? Some numerical values of K, Q and A. That is, on this type of problem, one can set any number of numerical problems by changing these values. With these values, in the examination, if the value of Q is equal to 1 microcoulomb, if the value of Q is equal to 1 microcoulomb, both are same, and A is equal to 1 centimeter, that is equilateral is 1 centimeter. What is the electric field at this point? For this set of numerical values, E is equal to question mark. That is why use this equation. Already we have arrived at the solution. E is equal to KQ by A square. Write the value of K in SI. That is value of K in SI into 1 microcoulomb is 10 to the power minus 6 coulomb in SI. And A is 1 centimeter, 10 to the power minus 3 meter. in SI. So whole square. So this will get cancelled. 10 to the power minus 6, 10 to the power minus 6. Remaining 9, 10 to the power 10 to the power 9 Newton per coulomb. That is the magnitude of electric field at this point. If the charge is 1 microcoulomb here, 1 microcoulomb here, and the distance of separation is 1 centimeter, magnitude of electric field at this point is, this is the numerical value what you get. So likewise you can change the values, different values, 10 or here 10 centimeter or 1 centimeter like this. Accordingly you can do the calculations. Next is, in the other problem there are 3 charges in space. Magnitude of each charge remains same. That is even sign also, plus q, plus q, plus q. They are at the vertices of a square. Square means all sides are equal, all angles are equal, 90 degree, 90 degree, square. And there is one point at the another vertices, there is a point is here. We have to calculate what is the electric field at this point due to these 3 charges. These 3 charges on the point are in this geometry of arrangement. That is, for this we need a geometry. Draw a geometry like this. Find the distance between this and this is a diagonal of the square, and the value is a into root 2a. According to Pythagoras theorem, write the value. What is the value? First calculate this. Draw the geometry. That is a like this, and length of this is a root 2. So with this, what is the distance between this and this is a. Distance between this and this is a root 2. Distance between this point and this is a. So with this, what is that symbols? We write what is the electric field at this point. By multiple charges means there are 3 charges, 3 electric field operates. That is E1, E2, E3. E1 because of this, E2 because of this, and E3 because of this. Because that electric field at this point, electric field at this point due to this charge is E1, and electric field at the same point due to this charge is E2, and electric field at this point due to this charge is E3. There are different directions. These are the directions we have. So net electric field at the point is, net electric field at this point is vector sum of all. There are 3 vectors. Net electric field at this point is vector sum of these. So let us write what is E1, E2, E3. That is E1 is equal to kq by a square, and E2 is equal to kq by a square due to this charge and this charge. And due to this charge is that is E3, kq divided by distance of separation is not a square. There a root 2 whole square, that is 2a square. That is E3, electric potential at this point due to this charge. But what is E1? Electric potential at this point due to this charge. And E2 means electric potential at this point, that is the direction due to this charge. Now vector sum means first we have to sum these 2, that is E1 and E2. What is E1 and E2? The angle of separation is 90 degree, because if this is angle 90 degree and this is angle is, this angle must be 90 degree. This is the angle because these 2 vectors are separated in by angle. Then you have to apply what is that E1, E2. Use the standard formula like this. What is the standard formula? This is the standard formula. And E1, E2 value remains same. The same. Therefore, E1 is equal to E2 is equal to E. Apply the same equation. It reduces to this equation plus E3. Find E1, E2, that is ER, resultant vector. That is ER means resultant of these 2. The resultant of these what is that? substitute for this. What is cos theta? Cos 90 degree. Angle of separation is 90 degree. Cos 90 means 0. The second term becomes 0. So only 2e square remains. Here after root, what is our root 2e plus e3? That is two vectors. This vector and this vector. And what is the direction of this vector? Resultant vector is the direction. And e3 vector same direction, same line. Therefore, we again further, what is that? Net, what is further addition means vector addition of these two. It is simply algebraic addition because same direction. Algebraic addition, same direction. Therefore, root 2, substitute for e. That is k cube by a square. Substitute for e3. K cube by 2a square. And simplify, take out this common factor k cube by a square into root 2 plus 1 by 2. That is net electric field. That is net electric field at this point due to all these charges for this geometry of arrangement is k cube by a square into root 2 plus 1 by 2 at this point. Net electric field. That is, what is the total electric field at this point? That is the one. That is a equation we arrived for this point, at this point. If we have different numerical values, suppose for different values of k, q and a, we can assign numerical values. Accordingly, this will change. For these numerical values, we can set the problem, any number of problems for different values of q and a. If q equals 10 micro coulomb for this set of values and a equals 10 centimeter, let us see what is the value of e at this point. That is k in SI and q means what is q? 10 into 10 to the power of minus 6 coulomb divided by a means 10. 10 into 10 to the power of minus 3. That is centimeter. 10 into 10 to the power of minus 3 meter whole square in SI. That is in SI. So when I simplify, this will get cancelled. 10 to the power of minus 9. This is 10 square. 10 square, this cancels away. Remaining is, that is 9 into 10 to the power of 9 root 2 plus 1 by 2 Newton per coulomb. Newton per coulomb you get. So that is the value 9 into 10 to the power of 9 root 2 plus 1 by 2 coulomb whole square. So please check it. 10 into 10 to the power of minus 6. This 10 to the power of minus 6 10 square. Remain 10 square. 10 by 10 square is 10. 1 by 10, no, this is 10, 8 you get. This is 8. 10 to the power of 8. So this is what 10 to the power by root 2 plus 1 by 2. So totally when you simplify get, it is a numerical value, that is net electric field at this point due to this magnetic broadcast Newton per coulomb. So this is how you can able to evaluate electric field at any point due to multiple charges. The problem is like this. And a final one, this problem is similar to equilibrium type. Similar to the one we have solved in the previous class on the basis of what is that electrostatic force. The previous class it is based on electrostatic force, not electric field. So equilibrium type. What it means there are two electric field operating where electric field, net electric field is 0 is called as equilibrium. So I'll choose the same type of problem here as you did in the last class. Here the two charges are there, that is plus 2q and plus 8q. The two charges, and you have to find out the point along the axis. This axis, no, axis also this side, axis also this side, axis also in between these two charges. At what point axis of these two charges, electric field is 0. That is E equals 0. That is equilibrium point for electric field. That means first you try what is the point in between these two charges. So when you take the point in between, when you see that two electric fields are in the opposite direction. A electric field at this point due to this charge is E1, direction is this because repulsion between this and this. And electric field at this point due to this charge is again E2, direction is this because repulsion between this point and this charge. These are the two directions, opposite directions. The point is here, anywhere in between here. You have to find out what is the point. Suppose if you place the point here somewhere this along the line, this side, then when you find the electric field, no, electric fields lie in the same direction. Here also, when you place the point along the line this side, electric field will lie in the same direction. Then if the electric fields are in the same direction, there is no point of equilibrium point. Equilibrium point is expected only when the electric fields are in the opposite direction. That is the point always between these two charges. Let us say the distance between these two charges is L and the point is this. If that is the case, if it is x, the distance between this point and this charge is x, what would be the distance between this point and this charge? L minus x. That is minus of this point. So you have to calculate what is the point, at what point E is equal to 0. The problem is the two charges are kept apart like this. You have to find out at what point on the axis the electric field is 0. That is the point I have taken here in between. You have to evaluate for that. So E1, that is E1 is the electric field at the point due to this same equation. That is K into magnitude of charges plus Q divided by distance of separation is between this point and this point you have taken is x. And what is the electric field at this point due to this charge? K into magnitude of charge divided by distance of separation, L minus x. What is L? Distance of separation between these two charges overall. E1 is this, E2 is this. This is general form. So what is equilibrium? E equals 0. At what point E equals 0? E equals 0 means E1 is equal to E2. So let us equate them and find what is the point in terms of x. So when you equate these two, when these two are equated, we get this point, that is equilibrium point with value of x. Equate and simplify, that is E1 is equal to E2 and cancel, what is that? This photo, all of them take to left hand side, remaining on the right hand side. This will cancel KQ and remaining 4. So whole square equals 4. Solve for this. So that is L minus x by x is equal to root of that. Root of this is plus or minus 2 we get. Just algebraic solution. So there are two possible values, case 1 that is plus 2 and other is minus 2. And check which is the one which is correct. This is correct or this is correct. For this value x is equal to, that is simplify this, x equals L by 3 we get. For this case x is equal to minus L we get. Look at that. When I solve for x for the case 1, when I solve for x for the second one, we get this plus value for L, that is acceptable solution. If you get L equals minus, it is not acceptable solution. So acceptable solution is always what is that L should be positive. That is x equals L by 3 is the true value, it is not true. That is at x equals L by 3, what does it mean? When x equals L by 3, 1/3 of the distance nearer to this is the point at which E is equal to 0. That is the equilibrium point. So nearer to this, that is 1/3. This is smaller charges and higher charges. So this is how we can calculate this point. What is the equilibrium point? So at which point E is equal to 0? At x equals L by 3, 1/3 of this distance, nearer this is the equilibrium point or E equals 0. So this is the one just similar that we have did in terms of electrostatic force, but we are doing it in terms of electric field. This is how we can calculate. This type of problems are very important in the examination. With this, you have completed. Thank you very much.